Alrighty guys, here we go. We're in Unit 2. We're going to talk about function notation. And when I was going through making up some lessons, this is my dog. This is my dog. He was about to eat my homework. Anyway, I just figured he looked kind of happy hanging out by my calculator and stuff. His name is Maddox. Hi Maddox. Okay, here's function notation. I need to show you guys how to do this, so I need something to play with. So I wanted you to see these are three different functions. One is called f of x, one is called g of x, one is called h of x. But I want to have a couple more to play with, so I wanted you to see. I'm just making these up off the top of my head to play with. So we're going to call this one j of x. And j of x, I'm going to make it 4 minus x. I have to have something to play with. I'm just making these up. That's how I made the other ones up. And then I'm going to do one last function. I'll call it s. So function s, what the heck? Let's make this one do 3 over x. That's what its job will be. Okay, so here we go. Let's play. Function notation is a labor-saving thing we use in mathematics. In Algebra 1, we introduce this concept to you. And here's how I like to introduce this idea. If y equals 2x plus 1, and we plug in x equals 4. What is the resulting value of y? 9. Y equals 9. If y equals 2x plus 1, and we plug in x equals 4, we will get 2 times 4 plus 1. The resulting value would be y equals 9. Now, that's not a difficult question. It's not. But look at how much I had to write to convey that idea to you. Function notation was designed so that we could take a shortcut. F of 4. What that says is I want you to go up to the function that is called f. Well, in this case, it would be this one. What do I want you to do? I want you to plug in a 4 there. Oh, well, I could do that. What would that mean? Well, it would mean 2 times 4 plus 1. Why? Because that's where the x was. Oh, okay. So function notation is like taking this whole sentence, big chunky monkey here, and what does it mean? Well, it means f of 4 equals 9. Hey, guess what? If I said, what is j of 4? What do I want you to do? Well, now I want you to look only at this guy. I don't want you to look at anything else. I don't want you to look at any of the other guys. Just look at j. And what does that mean? It means wherever you see the x, replace it with the number 4. So it would be, instead of 4 minus x, instead of that, I would say 4 minus 4. Well, what's 4 minus 4? It's 0. So you can shorthand. This is like a way to take shortcuts. J of 4 equals 0. Now, I'm going to use these same functions to play with for the rest of this time. So what would be helpful for you would be jot these down, because these are the ones I'm going to use to play with, or take a picture of them with your camera, with your phone, and you're going to see that I'm going to use the same functions over and over again. So here we go. I'm going to do just a couple more shorties. So let's try let's try, since I have j right there, I'm going to use j, and I'm going to say, what is j of, oh, I don't know, x plus 7? Well, that means wherever there's an x in j, I'm going to plug in x plus 7. So instead of 4 minus x, I'm going to say 4 minus x plus 7. Well, can't I distribute the negative then? Sure I could. And I'd get 4 minus x minus 7, but these are now combinable terms, so I could put them together and I could say negative x minus 3. So what is the result of j of x plus 7? It's negative x plus 3. Now, I want to do one that's super easy and then make it look complicated. So I'm going to focus on s right now. I'm going to go to the s function. And I'm going to say, whoops, I'm going to say a. The s function, what the heck, it froze up, guys. Why did you freeze up on me? Oh, there we go. Thank God. S of x, what did it say? S of x is this. I made it up to look like that. See, I'm not doing anything different. It's the same function. So what if they said something like this? What is S of 5? Well, what do they want me to do? They want me to replace the variable with 5. So I would say, you mean 3 over, not x, but 3 over 5. Yes, indeed, that's the answer they'd want, 3/5. Well, that's really easy. Function notation is not difficult. You just have to know how to read it. Now, let's take this and make it a little trickier. What if they said, what is S of 6? Well, S of 6 would mean 3 over 6. But then you'd say, wait, 3/6 is the fraction. It happens to be reducible. So, guys, here's the thing. When you guys do see the practice problems I made up a chunk of functions. I made up a list of functions that are similar to these ones. Not the same ones, but they're similar to these. I made them up. We're going to play with them. But remember, if you get a fraction answer, you are always supposed to reduce fractions when you work with a fraction. Now, this is what I meant, like, let's try and make this thing look kind of icky. What if I did something like this? What is S of 1 3/4? Now it's getting a little messier because I have now, well, what does this mean? It means 3 divided by, not x, but what do they want me to plug in? 1 3/4. Now that is a double fraction, or a fraction inside of a fraction. And if I want to punch this in on my calculator, I guess I could, but my calculator doesn't know how to deal with mixed numbers. So I'd have to change it to an improper, and I would have 3 over, well, 4 times 1 plus 3, 7/4. And that still looks ugly. Let me tell you this much. For the rest of this class, if you ever give me an answer that has a fraction inside of a fraction, it is automatically wrong. Now, let's analyze what this really means. All it really means is 3 divided by 7/4. And now it's not so scary at all. This is the same trick they taught us in the 5th grade. You flip and multiply, right? You flip that fraction, so what do I really get? 3 times 4/7, and I get 12/7. And I don't hate improper fractions. They're totally legit. Improper is fine. If it bugs you and you want to call it 1 5/7, it's also legit. But here's the rule. If I give you fractions in the original problem, give me fractions back. And if I give you things that are not fractions and they result in fractions, make sure that you reduce them. I'm running out of room there, so reduce it. Now, let's just understand that function notation is a shorthand way to say something like this. If y equals 2x plus 1 and we plug in x equals 4, what is the resulting value of y? Remember, f of x, g of x, h of x, whatever they say, it's just a fancy way to say, y equals. Now, I'm going to show you the most difficult thing we have to do is something called a composite function. And composite functions aren't that bad. Don't let them be that scary. But let me show you what they look like. And we're going to start off with a real easy pair of composite functions. I'm going to do this one. I'm going to say, well, first off, since I had to scroll down, f of x is this guy. That's my f of x, and I'm going to take j of x, and I'm going to use j of x. So we'll focus on these ones first, and I believe j of x was 4 minus x. Let me go make sure. I don't want to mess up. So j of x, yes, is indeed 4 minus x. Ooh, f of x is 2x plus 1. Whoopsie. So I'm using those functions. So what do I mean by a composite function? Here we go. F of j of x. Let that sink in for a second. A composite function is when you take one function and you plug it into the other function. So think about it. Look at this f of x thing. What does f of x do for a living? It takes whatever you plug into it and it multiplies it by 2 and it adds 1 to it. What is j of x's job? It's to be 4 minus x. So f of j of x would mean this guy right here. This guy is just code for this. I'm going to take this and I'm going to plug it in where the other guy has his variable. It doesn't sit next to the variable. It replaces it. It's called substitution. Oh, we've heard that. Substitution. Now, let's clean it up. This guy right here is not pretty. This is impolite. This is leaving work for somebody else to do. So we are supposed to, in this case, distribute. So I'm going to say, well, that would be 8 minus 2x. Don't forget plus 1. That's part of the deal. Then we could put 8 plus 1 together. So the final answer would be negative 2x plus 9. This thing, what is its name? It is called f of j of x. That's called a composite function when you plug one function into another. You will do this a lot in calculus. So let's try this. Let's go to this one. We're going to go j of f of x. I told you these ones aren't that bad. Well, hey, guess what? What does f do for a living? This is what f does for a living. J, on the other hand, says whatever you give me. I'm going to say 4 minus whatever you just gave me to replace the x with. So I am now going to distribute this minus, and I will get 4 minus 2x minus 1. I have combinable information. Grand total, I end up with negative 2x plus 3. This guy right here, his name or her name is j of f of x. Composite function. You're going to take one function and plug it into another. Now, I could do this with any of the functions. So I want you to see this one. I'm going to use, what the heck, I got f sitting right there, but I wanted to do this guy. I wanted to borrow my guy g right here. G of x, whoops, let's get him. Oh, dang it, I'm sorry. There it is. I lost my spot. I should have marked it with a box or something. So I'm going to take this. Heck, I'm going to use f, and I'm going to do f of g of x. Now remember, g of x, I just grabbed that from the top. Oh, where am I going to put it? I'm going to put it right here. G of x, what did it say? It said negative x squared. So if I do f of g of x, remember, this guy, he is just negative x squared. So what is he going to do? He's going to get popped into the slot here. So what does f of g of x look like? Not much. I mean, 2 times this, what do you get? You get negative 2x squared plus 1. That's what f of g of x looks like. So how tricky does this get? Well, this is about as tricky as we're going to get now, and we're going to see something like this. What about g of f of x? Composite function. What does this guy do for a living? His name is 2x plus 1. He's going to get popped into g. But what does g do? G says, I'm going to put a negative where the, and now look, I'm going to take whatever you give me and I'm going to square it. Now, I know that this is one of those things where somebody always messes up. And they say, I'm going to call this 4x squared plus 1. Don't do it. Oh, don't do it. I'm going to take those arrows away. That is so illegal. Now, you might say, no, I learned that in Algebra 1, that I could do that. You learned this in Algebra 1. You can do this. That's totally true. 2x, or 2 squared and x, you could totally do that. That is not wrong. But here's the thing. This is what's called a monomial. There's no plus sign or minus sign between these guys. Then it's totally legit. You can for sure, yes, distribute the power when it's a monomial. But you may not, drop it like it's hot, drop it like it's hot. You may not do that on a binomial. Why? Because a binomial, that means you are going to take 2x plus 1 times itself. Which means if you drop it like it's hot, you're going to miss it because this is now something you're supposed to FOIL. And don't forget, there's a minus out front. Well, what do I do first? Well, this was based on parentheses and exponents. Remember, exponents go before multiply by a negative, so you should FOIL first. I always say FOIL 2, then distribute it through. FOIL 2, distribute it through. So let's FOIL these first. And if I FOIL this stuff first, I'd get 4x squareds. I would get 2x and 2x, that's 4x. 1 times 1, I'd get a 1. But now I take that result and I say I'm going to run a negative through you. What's the final answer? Negative 4x squared minus 4x minus 1. What is this guy's name? G of f of x. Now, I wanted to have some playing pieces. I'm going to do this in color because I don't want to get too far away from my object here. So I'm going to use, I don't know, let's use blue. I think it'll show up better on the screen. So let's go back here. I'm going to this one right here. And what I'm going to ask you is this. What would J of f of 3 be equal to? What is J of f of 3? Now, why did I mention this? Because I already know what J of f of x is called. I made this function. I created it. So guess what? It just means if you already make a function, hey, I composed these two functions together is what you'd say. I can plug the 3 into the function that I made then. I could put a 3 right here. So if you check the answer in the back, it's going to be negative 2 times 3, that's negative 6, plus 3 more. The answer you'd find would be negative 3. What if I asked you for J of f of 5? What would you get? Well, you'd plug 5 into it. You get negative 2 times 5 plus 3, that's negative 10 plus 3. That would be negative 7 for an answer. That would be negative 7. Once you create a function, it's yours to use. So it's kind of a shortcut way to get there. So here we go. Let's look at the ones we just made. I'm going to use a red pen. Let's use a different color. So I'm going to take this one right here. I'm going to say, hey, f of g of x. I know what your name is. I created you. F of g of x. You are known as negative 2x squared plus 1. I am going to ask you, what do you think f of g of 4 would equal? What does that equal? I don't know. But what does it mean? It means plug a 4 into the x. Oh, okay, so f of g of 4 would mean negative 2 times not x, but 4 squared plus 1. Order of operations, 4 squared, I do that first, I get 16, times negative 2, I get negative 32, plus 1, I get negative 31. That would be the result of f of g of 4. Pretty cool. Now, here's the other thing. Let's do this one. This one's not going to be as easy, but what if we had something like, what is g of f of, heck, negative 5? Let's do g of f of negative 5. So, if you've already got the idea correct, let's see what you get. You would do, what now? Negative 4 times, what? Negative 5 squared minus 4 times, not x, but negative 5 minus 1. See, all I'm doing is I'm replacing every single x in this thing with a negative 5. That's all I'm doing. Because this is g of f of x. Now, you could either grab a calculator if you're paranoid, I don't want to make a mistake or whatever. But this is just negative 5 squared, so that's 25. I did exponents, now I multiply. 25 times negative 4, that's negative 100. Over here, negative 4 or minus 4 times negative 5 is going to be plus 20. And then take away 1. Let's combine this stuff together, and what do we get? Negative 80 minus 1 more. I think it's negative 81. But I got to tell you, I am making this video at 5:12 p.m. on a Friday. So maybe it's supposed to be 79. Nah, I don't think so. I think it's negative 81. Now, here's the mind blower. I could have taken a shortcut. I really could have. And I'd be definitely sure that the answer is negative 81. It really is. Here, let me show you my shortcut. My shortcut is based on this. Let's get another one. We'll go Christmassy colors. Let's go green. Remember, what was g of x? G of x had a name to it. It was negative x squared. Yeah. F of x up above had a name to it. Yeah. F of x was 2x plus 1. If I want to know what g of f of negative 5 is, I could also do it this way. I could do it by plugging negative 5 into f. I could plug negative 5 in right there. If I did, I'd get negative 9 out of the function. I would get this whole chunk would equal negative 9. I believe I am correct. Then I could take negative 9 and plug that answer into g. Now, don't get messed up here. The negative is not like this. That's not what g says. G does not say that. So I am not going to treat it that way. Just the x part is getting squared, then you put a negative. So order of operations, you would say negative 9 squared. That's 81. Then you make it negative. So the answer is negative 81. See, it's got to work either way. When you plug a number into a composite function, that is a function that you already created by plugging a function into a function. If you do it that way, it's totally legit. You can do it. It's not illegal. But sometimes it's easier to do it what I call two-step approach. Plug it into this guy first, then plug it into that guy. All right, so here's what happens when we're doing function notation. You're playing around. You're plugging stuff in to see what happens. So let me show you this one, because I haven't shown you this guy yet. I wanted to do this. See this guy right here? And this guy right here? I want to do a little messing around with this one. So, h of x and s of x, I'm going to use those two. I'm going to go down below so we can use those. Let me get I don't know what I did there. Sometimes I hit buttons on this. I don't know what I'm doing. So here we go. H of x and s of x. So we're going to do an h of x, which is, and s of x, which is this, I believe. Let me double check. I don't want to ruin what I've done so far. So what does h do for a living? It says 2/3 times x. S does for a living 3 divided by x. Okay. And that is what I have. So here we go. Let's suppose I want to do S of h of x. So that means S of x. That means 2/3 x is going to get plugged into S of x. But here's my question. Does this variable x, does it go with the top number, with the 2, or the bottom number, the 3? Because they didn't put it clearly in the top or the bottom. Take a guess, because there is an actual answer, and I'm going to have to share that with you so you never get this wrong. When they type up math books, a lot of the time they'll put the variable right in the middle of the fraction. Unless they put it clearly in the bottom of the fraction. See how in this one it's totally in the bottom. There's no mistaking. If they put it in the middle, like on h here, then it goes with the top. So you can always interpret this type of thing here. It's the same as this. So let's begin. If I take h and plug it into s, s does this. It'll say 3 divided by, and then I would have this. Now the reason why I really gave a big stink about that, why I really cared whether or not you correctly use this, is because this brings us back to something I talked about before. Never ever give me a double fraction or a fraction inside of a fraction. It's always wrong. What does it really mean? It means 3 divided by 2x over 3. That's what this means. This is just a fancy way to say divided by. And this is still the same thing they taught us in the 5th grade. 3 divided by 2x over 3 would be 3 times 3 over 2x. Now in algebra, hang on, I want to do this for a second. I'm going to erase this. This is why they stop using x to mean multiply and they do stuff like this to us. Because there's already variables of x and we don't want to get anyone confused. So it's all a big game of let's try and not confuse people. But 3 divided by 2x divided by 3, that just means this guy. So do it. What is it? 3 times 3 over 2. There it is. There's my answer. So I hadn't shown you one like that yet. I hadn't shown you one like that yet. So I wanted to make sure that you knew how to interpret that correctly. That's how you would do it. Now, once again, hey, I'm going to change colors on us. Let's see, how about like a dark blue? What if they said, hey, buddy, now you know what this is. Could you tell me what that is? And I go, sure. Now, to me, it would be so much easier just to put the 5 in right here. I have a choice. I could either do it, plug 5 into H, and then take that answer and put it into S. Or I could just say, put a 5 right there, and that's the same as 9 divided by 2 times 5. Heck, my answer is 9/10. That's my answer, 9/10. Bam, done, finished. So here's what I want you to see. I want you to see the practice problems. Here they are. We're in Unit 2. Well, Honors Alg 2, we're in Unit 2. So here we go. I have 35 questions, but you know what? Don't freak out and go, that's a lot of work. But I do want you to understand, I made up different these are not the same functions I just did. These are different. These are made up for you guys to use. So in problem number 1, where it says f of -5, please don't plug it into the one I used for my, use this guy, use this one. But hey, guess what? let's do the first one together. It's so easy. F of negative 5. What does it mean? It means you take the negative 4 times, not x, but times negative 5 squared. Negative 5 squared is 25. 25 times 4 is negative 100. Now guess what? You could probably do that in your head. If you did that in your head and wrote down the answer negative 100, I would totally believe that you were able to do that in your head. Why? Because it's not that hard. But when they get more difficult, by the way, I'm looking at this one. This one looks kind of like I spazzed out. This looks like that's a 2. That's a 2. Negative 3/2. That's supposed to say h of negative 3/2. Now let's take a look at what number 3, because that's really poorly written. Now this one, what does h do for a living? It says whatever you give me, I'm going to multiply it by a 3, and then I'm going to add 1/4 to it. So you'd end up with, well, let's multiply it, negative 9/2 plus 1/4. So you know what? You might want to show me a little work on problem number 3. You might want to treat that a little bit differently. But here's the long and short of it. On some of these problems, you can do them in your head and I can do them in my head. You just write down the answer. But some of them, you probably should show me some work. But either way you slice it, here's the answer key. Okay? Take a picture of it. Now, go for it. You got it. Now, one thing I want you to keep in mind, though. 13, 14, these guys right here, even this guy, I'm scoping those out really quick. Hey, you have to sometimes get common denominators to add things together. Sometimes you will need common denominators to add things together. So keep that in mind. I believe the ones I just checkmarked there need common denominators. That's only 1, 2, 3, 4, 5 of them, but I want to see if you guys remember how to do that. That was an Algebra 1 skill that you had to practice. Now, once again, use these made-up functions, f, g, h, j, and s. They're different than the ones I used for my examples. Now, here's the other thing I want you to do. When you do the problems, do them in order. So you'll see, like f of j of x here, number 7. If you do problem number 7, you will get f of j of x. You should then check it and make sure that it is correct. Then, when you get to problem 8 says, what's f of j of 4? Well, that means you have an option. You could either plug 4 into your new function, or you could do it two-step approach. Whichever way is easiest or easiest on your mind, please do it that way. Please do it that way. Now, heck, I want to make sure that my hunch is right. So I'm going to look at number 32 here. Number 32, the answer for 32 is, what is that? Negative 5x, get this out of my way, I don't know what that is, plus 18, the whole thing over 6. So let's see what was the question for 32. It says s of j of x. So what is j of x? 5/6. Ooh, they did one of those. Look, does the x go with the top or the bottom? It goes with the top. So it's like saying 5x plus 6 is going to get plugged into s. What does s do for a living? S does this. S says 3 minus whatever it is that you gave me. And then this is what I mean. Hey, this guy's got a denominator of 1. This guy's got a denominator of 6. We'd have to get common denominators. So I'd have to say multiply the bottom by 6 and the top by 6. That would give me 18/6 minus 5x over 6. And then they have a common denominator. I can put them together. But guess what? You should always put letters before single numbers. All the single numbers. Whenever you have a variable and a single number, you should always put the thing with the variable before the single number. No matter what it is, all the single numbers. oh, 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 oh. All the single numbers, all the singles. Okay, sorry, that was a bad joke, but it's Friday and I'm silly, I guess. Here we go. That is an example of a problem where you need to find common denominators, number 18. So, just remember, guys, as always, I will embed the practice problems. There they are. There's your practice problems for this. There's your answer key for this. Check them as you go through. Ask questions in class when we go together on Zoom. And do your best. All right. And remember, sometimes your dog will eat your homework. That's Maddox. He's a nice dog. All right. Catch you guys later. Bye.